Today we're going to talk about factoring quadratic polynomials. This is a specific type of polynomial where the degree is 2. It usually has 3 terms. It can have 2 terms, and we'll see what the rules are and how we go about doing this. So we start out by looking at the general form of a quadratic. Say we're asked to factor ax squared plus bx plus c. So in general, if we were to factor this, it would come out in the form px plus r times sx plus t. Now, if we were to FOIL that, our result would be ps x squared plus parentheses pt plus rs parentheses x plus rt. Well, going back to our original expression in the general form ax squared plus bx plus c, we can see that rt would simply equal c, pt plus rs would equal b, and ps would equal a. So this already implies how we would proceed to factor a general equation. So let's look at an example. So let's say we were given x squared plus 5x plus 6, and we were asked to factor it. Okay, whenever you're giving a quadratic in this form, or a trinomial, the first thing you need to look at is the signs. Notice that how both signs are positive. Also, you need to look at the fact that the first term, the x squared term, has a coefficient of 1. Well, this immediately implies something. All right, we immediately know that in order to get the x squared term, we must have x times x. That's the only way we can get that. Also, if we look at the signs, they're both positive, so that means both of these signs are going to be positive. So we're going to have a positive sign here and a positive sign here. Now you need to look at the 6. What numbers multiplied together are going to give you 6? Well, it's either going to be 6 times 1 or 3 times 2. Well, it can't be 6 times 1 because 6 plus 1 is not 5, but 3 plus 2 is. So therefore we know that this number right here is going to be a 3, and this number right here is going to be a 2. And now we have factored. And the beauty of factoring is the fact that we can always check our answer. If we FOIL x plus 3 times x plus 2 together, we should get x squared plus 5x plus 6. So we can always check our answers whenever we're factoring. All right, let's look at another example. Now I've got x squared minus 5x plus 6. The numbers are exactly the same. The only difference is the middle term has a negative and the constant term has a positive. Well, how do we get positive 6? The only way you can get positive 6 is you have to have both the signs positive as we had before, or negative, in which case this is what you'd get. So our result would be x minus 3 times x minus 2, because minus 3 times minus 2 is positive 6. But then if you were to FOIL this out, you'd have minus 3x minus 2x, which gives you the middle term of minus 5x. So here's another example. Same numbers, different signs, and this is the result we get. All right, now we have a third example. Same numbers again, but again, notice the signs are different. Now the middle term is positive and the constant term is negative. Well, think about it. How are we going to take and get a result here? So with that last constant term being negative, the only way that can happen is if one sign is positive and one sign is negative. And again, we have to have factors which give us 6. So it's either going to be 6 and 1 and 3 and 2. But we notice that it has to be the difference now. The difference of 6 and 1 or the difference of 3 and 2. Well, 3 and 2 difference will not give you 5, but 6 and 1 will. Now, how do we get the positive sign here? The larger number, the 6, gets the positive, and the smaller number 1 gets the negative. Again, FOIL out x plus 6 times x minus 1, and you should get x squared plus 5x minus 6. All right, our last example here, again using the same numbers, but now switching the signs again, has both signs being negative, the constant term and the middle term. Well, we already know that in order to get the negative sign on the constant term, we have to have one positive and one negative, which implies, again, we're going to go for the difference. So we can't use 3 and 2 because the difference is not 5. It's going to have to, again, be 6 and 1. But in this case, the larger number, the 6, is going to have the negative sign. So our result will look like this. So our answer is x minus 5 times x plus 1. Again, FOIL it out to check your answer, and you should get x squared minus 5x minus 6. So these 4 examples here show you pretty much what to do with the signs whenever the leading coefficient is a 1. So now what if we do if we have an example like this of 6x squared minus 5x plus 1? We still can play around with the signs, noting that the middle term is negative and the right term is positive, so both signs are going to have to be negative in order to get the right term positive. But we no longer have a 1 in front of the x squared, so what's that going to do? Well, if we do a little trial and error and check our answer, we'll find that the answer should come out to be so you can see that if we FOIL this answer out, we should get the 6x squared minus 5x plus 1. Minus 1 times minus 1 will give you the constant term of plus 1. The middle 2 terms will give minus 2x. The outside 2 terms give minus 3x. Add those together, you get minus 5x. And then lastly, the 3x times 2x will give you the 6x squared. So now, what if I get a very general example? We got 2 terms, 3x to the 6th minus 48x squared. Well, remember, the first rule in factoring is to look first to see if there's anything common. And if we look closely at this, we've got an x squared, we also got a 3. So let's factor the 3x squared out and see what we get. So we end up with 3x squared, like I said, times x to the 4th minus 16. Well, are we finished? Well, look what's in the parentheses. We've got 2 terms separated by a minus sign, and those 2 terms happen to be perfect squares. So this is the difference of squares. So let's keep going for another step here and see what we get. So our result now is 3x squared times x squared plus 4 times x squared minus 4. Well, are we done? Well, not quite, because we've got another difference of squares here with our x squared minus 4. So let's factor that and see what we finally end up with. So our result now is 3x squared, parentheses x squared plus 4, parentheses, parentheses x plus 2, parentheses, parentheses x minus 2, parentheses. And we can't go any further. The x squared plus 4 is not difference of squares, so at this point we have totally factored our original example. All right, now I would like you to do problems numbers 3 through 8 of the oral exercises on page 191 in your text and post your answers in the Dropbox. We'll go over these and any other questions you might have next time.